Okay, today we're doing exponential functions still, but just a little bit more added to it. We're going to be talking about compounded interest and half-lives. Okay, half-life is more of stuff that you'll see in chemistry, biology, and your science classes. Compounded interest is talking about money. We've done simple interest, stuff that's being growing at an interest rate of whatever percent. So now we're just talking about it being compounded. Compounded means it is happening more than just one time per year. Okay, so this is your function. As you can see, there are parts that are the same. We have y equal to a. A is still that initial amount times 1 plus. It's always going to be plus because we're talking about interest growing. And now we have our r like normal. We have the rate, but now it's being divided by this n. And we'll talk about what n means in a minute. And it's going to be raised. My exponent is now n times x. X is always going to be the years. N here is the same n up here. So whatever number you have for n here is the same number you're going to plug in at the top. For our half-life, function is y equal to a, still same, the initial amount, times 0.5. That's always going to be the same because 0.5 is half. 1/2 is a decimal. So you're going to have 0.5 raised to the x, and x will be the years or number of times that it is decreased by half. All right, so going back over what n will be. So what n will be? Semi-annually. When something is compounded semi-annually, it's going to be happening twice. Just like you have a semicircle. Okay, a semicircle, you have two halves. It's going to have two things. If you do something that is compounded semi-annually, you're going to put a 2 here and a 2 here. If it's quarterly, you're going to plug in 4 for n. If it's monthly, there's 12 months in a year, you're going to plug in 12. If it's daily, 365 because there's 365. If they do weekly, for whatever reason, they normally don't, but it'd be 52 because there's 52 weeks in a year. Fun fact for you if you didn't know that. Okay, so we're going to do some examples. First example, Edward has $60 in a savings account that earns 10% interest, compounded semi-annually to the nearest cent. How much will he have in 2 years? So I underlined and annotated the important stuff. After I've done that, I realized 60 is important, 10% is important, semi-annually is important, and 2 years is important. I'm going to write down my function. Okay, so write down the normal function that I would have, and we're going to plug in what we know. So my function here is the same as what we just wrote down, talking about compound interest. My A, I underlined $60. That's going to be my starting point, my initial amount. A is my 60. My rate is always going to be the percent, so I need to change this percent to a decimal. 10% change to a decimal is 0.10. Okay, just move the decimal over twice, like we have been doing. Okay, so I get 0.10. My n is 2 because it says semi-annually. So my n is semi-annually, and that gives me 2 for my n. And then it said for 2 years, and x, remember, is always time. It's always going to be in years, and I'm going to have a 2 there. So then I just plug all this stuff into my function. So I start with 60 for a, the 1 plus 0.10, because that was my r, divided by n, which is 2, raised to the n, which was 2, times x, which is 2 as well. Okay, so I had 2 here and a 2 there, so both of those are 2's. And then I just have that in my calculator. I know 2 times 2 is 4, so I can go ahead and plug that in for my exponent. And when I plug this in my calculator, I get $72.93 because it said to the nearest cent. That's the nearest penny. So I don't just have 92.9. Okay, I need to have $92 or $72.93. That is to the nearest penny. That's how you do it. You annotate, write down what you know, plug in what you know, and type it in your calculator. It's very easy. Half-life. Half-life of a here's your example for half-life. Half-life of a radioactive kind of francium, I guess it's some type of whatever, is 5 minutes. I don't know science at all. So that's some type of organism. How much will be left after 15 minutes if you start with 64 grams of it? Okay, so again, here's my function. I annotated the important parts. After 15 minutes, 5 minutes, and 64 grams. Okay, I know my initial part is 64. That's always going to be my A, so I'll plug in 64 for A. I know my 0.5 is still going to be in parentheses because it's half-life. Okay, then my X. This is how you solve for X. When you're dealing with half-life problems, they're going to tell you the span in which it's going to decrease by 1/2. For this one, it said the half-life of a radioactive kind of francium is 5 minutes. So every 5 minutes, it's split in half. Now the time frame that they wanted to find was 15 minutes. So to find the actual x that I'm going to plug in, I take the 15 minutes, divide it by 5, and I get 3. So that is what I put up here. And the reason I do that, 15 minutes was the span that they wanted, and over those 15 minutes, it's going to decrease by half 3 times because I divided it by its half-life time. When I get that 3, I plug it in, type it in the calculator, and I get 8 grams of a radioactive kind of francium, whatever francium is. Okay? Very easy. Another compounded interest. This one I did not annotate because I want you to annotate the important parts after you realize what I've written down. An investment is growing, so there it tells you it's a growth, at a rate of 6% each year and now has a value of $10,000. What is the value of the investment in 5 years if it is compounded quarterly? Alright, so the important stuff. 10,000, a rate of 6%, compounded quarterly and 5 years. A is 10,000 because that's my initial amount. R is 6%. I change that percent to a decimal. Move it over twice. I have to have a filler 0 there, so I have 0.06. That is my rate. It says what is the value of investment in 5 years. There's my x, so I plug that for x. And it's compounded quarterly, which means n is going to be equal to 4. So I'll write my function here. That's my function that I'm going to write down. That's always the thing you need to write down. Then I plug in what I know. Based off of what I've written down over here, what you annotated in the problem, you plug this stuff into the function, type it in your calculator once you have it set up, and you're going to round to the nearest penny, the nearest cent, which looks like it is $13,468 and 55 cents. Okay? It's very easy once you get the hang of what is what. Once you know what A is 10,000, R is 6%, N is 4 because it's compounded quarterly, and my X is 5 years. Write down what you know, plug in what you know, and type it in the calculator. Pretty simple. Last one, half-life. Again, annotate what you need to know to answer this problem. There's a population of 100 bacteria in a colony. If the number of bacteria splits in half every 460 hours, so it takes a while for this to split in half, what will the population be? I guess there should be an n 920 hours from now. So, write down your function, a times 0.5 raised to the x. To find x, again, I need to divide the time span that they want by the time span it takes to split in half for this bacteria. The half-life for this bacteria is 460 hours. They're looking for 920, so when I divide 920 by 460, I get 2. That's what I plug into my exponent. So I take the 920, which was the time that they wanted to see how long it was going to split in half or how much I was going to have left, and I divide that 920 by the half-life. Okay, it splits in half every 460 hours, so I divide 920 by that 460. That gives me a 2. I plug that in, type this in your calculator, and I should get, there's going to be 25 bacteria in that colony based off this scenario. Okay, so annotate what you need to know, write down what you know, plug in what you know, and type it in the calculator. It's very easy once you annotate and read the problem.